the JavaScript full stack FHIR development talk. So, about the speaker. That's me, Abigail Watson. I'm a clinical informaticist from the Chicagoland area. I did my undergraduate and graduate studies at the University of Chicago. And I'm here to talk to you about full stack development. I do a consulting business where we've been called Symptomatic, where we've developed a product portfolio of different applications. And this isn't going to be a sales pitch, I promise. We're going to talk about how to make full stack JavaScript applications and the technology we use to make narrative medicine applications, personal health records. We have epidemiology apps, all built on JavaScript using FHIR. And our marquee product is a longitudinal timeline. And we're going to talk about what you can do with JavaScript. We're going to actually skip some of the videos. We'll loop back around to it. But full stack JavaScript, we got pretty excited. I started off my career as a EHR admin, doing a lot of MUMPS administration, Cerner administration. And around the time of the Affordable Care Act, I got bumped over into the vendor side. And the name of the game was, let's build a web application that was HIPAA compliant, FDA, or connected to an EHR. Those were like the three tasks that everybody had. And we kept, we were looking for a JavaScript framework. And about 3 or 4 years ago, we stumbled upon Meteor, which if you're familiar is a full stack JavaScript application. They use JavaScript on the server, the client. But what they provided an API documentation. And when we started down the side of, like, let's build healthcare apps for with JavaScript, we were looking for our .NET. I mean, we were looking for our framework. Is like what takes JavaScript and puts it all together so that we can actually use it. And Meteor was purporting to deliver that, to give us to JavaScript the .NET style framework. And so it includes things like all these like server maintenance functionalities, accounts, passwords, a user interface. They kind of had worked to put it all together. And we were enamored by this. At the core of Meteor is the build pipeline. It's a compiler by any other name with an interpreted JavaScript engine. And for those of you who follow Chrome and the browser wars, there's the V8 engine, and particularly Meteor targets the V8 interpreter and takes a bunch of libraries and packages from the JavaScript ecosystem and builds a web app with them. Interestingly, Meteor purports to have isomorphic code, which means that it uses this V8 interpreter both on the database, the server, and the client. And now we're starting to get some interesting ideas here because, as many of you know, the FHIR specification is available in JSON, and here we have the architecture, the interpreter architecture, to interpret JSON and FHIR resources across the different technology parts of your stack. So after mapping out all of this, we sort of started extracting what, where does JSON and where does FHIR potentially fit in all of that. And so we're going to break this diagram apart, but this is our microservice architecture where we have server on the left side, client on the right side, and these are the different data cursors that are doing aggregate, map reduce, RESTful endpoints, our pub sub architecture, components and then onto the display. So long story short, we started taking this Meteor platform and saying, let's add fast healthcare interoperability resources into this. And we started pulling best of breed libraries. We wanted to make sure that we got Material UI in there, D3 analytics, all your fun exotic databases. And these were requests that we were receiving from different consulting groups and different projects, different client projects. And we built this whole architecture, which if any of you are familiar with a data lake architecture, you'll see some similarities to your data lake architecture. And the result is you have a FHIR resource in, this is an observation resource that is being pulled up in the browser console. So you're in your web browser, you're in Chrome, you inspect, and we have the FHIR observation resource type. We also have our database. This is a Mongo database administration tool, and we have FHIR resources. That same resource is now in our database. And we also get it on the server logs. In this case, this is on a cloud-hosted infrastructure, Amazon, Galaxy, all that. And we have the risk assessments, patients, you can see them being line itemed in there too. Long story short, we have this data layer and are getting the FHIR on all the different components of the stack. And that was really excited. It got so exciting that we went and we made a whole repository or a organization in GitHub. So the Clinical Meteor organization on GitHub is available. It's all open source. We have been trying to, we have a software development kit. It has somehow 1,600 stars. It's gained some traction. But we try to keep an eye on the JavaScript ecosystem. The goal with the Clinical Meteor project is we wanted to take that full stack JavaScript framework, fork it to include HIPAA readiness, FDA readiness, get the FHIR resources in there, and then publish it all somewhere. And the software development kit is where we started kind of tracking everything. This grew out of the Meteor cookbook. We were keeping recipes for building JavaScript apps for a very long time, and it grew into something else. So Clinical Meteor now has 170 plus packages. We took a different approach with the resource classes. And it's a very common pattern. People say, let's import all of the FHIR JSON schemas and let's build one library that handles all of them. We took, and I call that a horizontal approach. We took a vertical approach where we wanted to create a package. This might not be, if you were to scroll down, we have a package for every resource. So we have a H07 patient package, we have an H07 observation package, and we do what I would call a vertical architecture in our package management approach. Nonetheless, Meteor on FHIR and a bunch of other things, we put this all under quality control. We run continuous integration across the base platform as a service to other JavaScript developers who want to make sure that there's some level of quality control. And we've also been working on getting the packages through the Aegis touchstone conformance testing. So, you know, the JavaScript open source is really fantastic. One of the big things is when everybody is kind of doing their own thing and you've got the bazaar, where's the quality control? And so we're focused on how do you pull all these libraries together, put them all in one place, and then sort of synthesize them down integrate them, get them under quality control so that you can build software. To date, the clinical Meteor project has been through about 50 prototypes. We did 5 clinical trials projects, maybe 6 now. Social health record, genomics utilities, medical device integrations. We've been getting a lot of donations in the blockchain space, and so that was an easy community yield for us, so we're just like, oh, okay. We're piloting in multiple medical centers, have been doing App Orchard prototypes, and we've even run through AI and blockchain pilots with this. So it actually kind of works. What's new in 2018? Since the last FHIR DevDays, we have seen movement with the simple schema package, and so there's a lot of movement towards actually adopting the JSON schemas, and we have some libraries that the Meteor architecture used to have its own schema library, and the schema management is converging to JSON schema. It's not quite there yet, but we're seeing movement. SimpleDDP, for people who like WebSockets and their procedure request work lists, anything that's like an ancillary-driven workflow, this is the bee's knee. This is for doing pub-sub. I'm going to publish yesterday's patients in radiology, and I as a radiologist want to subscribe to just the CT scans of yesterday's patients because that's what I'm, so the SimpleDDP library has really some good improvement there. TensorFlow got released to the JavaScript community, and so we already hear some rumblings about TensorFlow on FHIR and how can we just streamline that. And QEWD, it sounds quick and easy web developer. What's really interesting is that the dependencies include cache and GTM, which is Mongo mumps, if any of you are aware. And so somebody donated us our mumps integration within the past few months, and so we're very excited about that. So we see the name is so understated, but there's so much good stuff like buried in this project. Yeah, QEWDs, we're excited about this integration. So the FHIR microservices, how do we put all this together and make applications with this approach? We talked about this diagram, server on the left, client on the right. And in our full stack development environment, we get a lot of this kind of syntax. Export default class, potential detail, extends React component. You've seen this kind of stuff. Data patient equals patient.find1, session get selected patient. From a clinical reasoning perspective, this is super convenient when you're, as a developer, trying to reason through, well, I get the patients here, I need to figure out which observations I have. The syntax really works. It's very productive. Text field, get this data.patient name text. That's similar to FHIR path in some regards, but we're grabbing the object and saying use dotted notation to drill into the tree and just grab this field. And so we have all the helper syntax worked out, and that's sort of how you would be in the UI component. The subscriptions, if package, if I have this resource package, and I want to publish a subscription patients, and this might be your patient work list. Give me yesterday's radiology patients. Meteor subscribe patients. That syntax is running both on the server and client. It's isomorphic. It's the same shaped. And so you get the same API on both the server and the client and one language to implement and return patients find. The JSON schema we're talking about, what's interesting is both the server client database to some extent, they get the full copy of the code. They get both the server and the client code, and there are blocks that say if client, if server, and some of it just runs anywhere. So patients, new Mongo collection, that'll create your Mongo cursor server client database. And then we have our simple schema that allows us to do nested schemas and add them so that we can approximate the schema hierarchy that FHIR defines. Webhooks are super exciting. Webhooks allow us to do data pipelining with this architecture. So patients.before insert, patients.after insert, common approach on all the database functions, insert, find, update, remove, upsert. We're going to show how this chains together into bigger applications in just a moment. REST endpoints, obviously, the Meteor, the clinical Meteor architecture went through a curious evolution in that it was originally designed by a group of MIT alumni, and they had been working with WebSockets and PubSub architectures back in the day. They had been really interested in getting this publication subscribe functionality working as a data architecture approach. And so we inherited like a whole platform that was optimized on the WebSockets. So for anybody who has been thinking about subscriptions, we started with the subscriptions and then had to, with time, add the JSON routes, the RESTful routes back in because it had already been optimized out. So we went back and we added the JSON routes, and you can see this kind of syntax. And so that's our day-to-day with full stack JavaScript. Well, it's not completely true. We also do our testing with FHIR. We put the FHIR objects in our validation tests running through Nightwatch, Mocha, and other. We also see, we have one group that does hardware development, and they prefer the Tessel microchip, and we've seen FHIR get down to the microchip level, and the so you can take it into a bunch of different places. These are the different resources that we had been talking about. Is like if you search Clinical Meteor for the resource packages, they're all broken out, and within each one, you'll see a package that we're not going to read all this, but that's the sort of the rhyme and rhythm of what full stack JavaScript looks like. You'll see that syntax, and you can read through this as a fairly cogent description of clinical workflow. I'm not going to read all this. Webhooks and data pipelining. So once you have this microservice together, like let's take that mental diagram that we've been talking about and make it vertical, because we're going to put multiple of them together. We find a lot of success in data pipelining. So if this is like patient and observation and results, you might chain them together. So after I insert a patient, fetch me all of their observations, calculate, and then put into the results, the diagnostic report. And so that gets exciting. That starts being interesting. Then you do it more. And now we have users and collaborators and studies and questionnaire resource. This was the microservice architecture for a clinical trials application. And we took their use case and said, you know what, you have a bunch of clinical trial stuff that's not completely modeled by FHIR yet, but you do have questionnaires, patient specimens, questionnaire response, and compositions, and these can be well modeled by FHIR. So we're going to stand up a microservice for each one. There's some other microservices, but then we start integrating it all. And once you get the hooks in place, you can kind of trigger them from a bunch of different places. And so there's a little, you find that both of these are accurate. They're just kind of different pathways, whether you're going through the user interface or receiving from an external system. And so if we were receiving post messages or V2 messages, you get something like this. And then you piece all of that together into like an actual clinical workflow. This is actually only sign in and I think log and observation, but you can really piece it together if it's a lot, but that's how you do it. Scaling, we've been running this through various levels of data warehouseness. The architecture is built so that you can start with just a server client. Mongo then scales up to a replica set. You get they go in threes, and then you do it into a whole cached, a whole sharded cluster. It goes up to petabytes and all that. So after this talk, we're going to be in one of the classrooms with for people who are interested in getting started. You know, getting started with full stack JavaScript, at least with our platform, is just a matter of diving into the Meteor documentation. And from there, you get to the Meteor on FHIR project, and then installation instructions. And so we'll be going over how to clone the repository, spin it up, add packages, edit the packages, and all of the rest. So thank you. We're going to be doing the walkthrough of the tutorial in the subsequent in the classroom this afternoon, and you're welcome to join or ask questions. Any questions about the state of full stack JavaScript or yeah.
Sorry, I'll start over again. So this is within the Meteor framework. I'm wondering, in terms of you come to this, say you do plain vanilla Node.js, or you have some other frameworks, how much of this splits out and can be used completely independently of Meteor or the particular parts, or in terms of building up a general JavaScript
absolutely
ecosystem for FHIR?
Yeah. So what I would actually... I know exactly. Let's go back to our build pipeline. Meteor, so there's a question about the idea of integrated systems versus best of breed and take the best library and so forth. And the premise of this talk is actually get it all integrated. Let's do full stack. Let's have FHIR and all the components. So one language, one data model across all of it. So what happens is as you add the libraries in, you find that there's mismatches, and you have to kind of paste them over and do the gluing together. But the more that you glue them together, the more integrated they are, they can't stand alone. They get the tighter dependencies, and you're like, well, so Meteor, the build pipeline has, they actually have been moving towards NPM. They started off with their own package manager, but in an effort to, they saw that the ecosystem was moving, like you say, towards NPM and different libraries. So they've been They built their own package manager, then they unbuilt it, and that's why there's these two steps. There's the Node package manager and the Atmosphere package manager. For this reason, is so that you can split parts of it out. If you dove into the code, you'd understand, or like, I mean, it's kind of hard to describe. To the point, yeah, you can turn off the user interface rendering and just use it as an Express replacement. Conversely, you can get rid of the Express and just use it to launch your user interface and grab it from an Express or a different. The whole thing is completely modular at this point, and we are bringing in, like QEWD is an Express project that we wrote in. So it didn't start off that way, but they've the maintainers of our upstream project have committed to supporting all the different NPM libraries and JavaScript libraries pretty robustly, and we rely on them, and it's worked well. So, any other questions? Nikolai.
You.
Hey.
Can you hear me?
Yes, please.
Thank you. Can I make some announce?
Go, please.
Yeah, so first of all, in Zulip, we have the JavaScript channel, so you're welcome to join and ask any questions. And in a couple of hours, in the back room, we have the brainstorm about FHIR JavaScript Foundation project. It's a small room, but if you're really interested in JavaScript, join us.
Any other questions? Yes.
Hi. In the creation of each of the packages for each of the individual resources, do you use code generation to create those off the file?
Yeah, great question. So we tried. With those 50 different prototypes, we tried a whole bunch of different mechanisms, and actually much less than you would think. A lot of it is handcrafted. And a good example of why that is to take a look at a resource like location. Okay, so location benefits from having a two-sphere index in Mongo. You can optimize the Mongo database to do geospatial queries with that resource. And so you have these one-offs. You have every resource has it is its own resource precisely because somewhere along the way it has one-off rules. So patient might have a photograph. Observation might need LOINC or SNOMED lookups. Location needs a two-sphere index. And so the code automation tools tend to require the one-offs as inputs to generate that code. And that is, it turns out that it's precisely the same amount of work to support those one-offs in upstream as it is to just support it in the package. So we do have, there's a whole lot of auto-generatedness, but it tends to be like how React builds out its DOM tree. And you're kind of like, the resource packages are there to have been the handcrafted interpretation of what the FHIR specification is. Any other questions? Yeah.
So right now your current support is for STU3?
We support DSTU2 and STU3.
And future plans pretty soon
R4,
for
yeah.
R4?
Yeah, well, we have a lag time, but the intent is, yes, it will be going in.
Okay, so is it the same stack then across all versions of FHIR, or do you
Yeah,
have specific packages for each one?
Okay, so that's a curious question. So Meteor actually is a schema-less architecture by default, and so we were really interested in that because from my experience as an EHR admin, I was completely aware that the data is going to come in all sorts of different, and not just even different schema versions. There's also the question of just incomplete data. So, so we took an approach where the validation is opt-in, and so you can receive data through the webhooks and RESTful interfaces, and it just writes to the database, whether it be DSTU2, STU3, whatever. And then we run through the validation on the uptake, is pick it up and check and before you do anything with it. So yeah, in that regard, we're a little future-proof because the technology will just kind of write down whatever it receives. Yet we're also looking at how to make the structured schema support. And yeah. Anything else? Did I zip through my presentation? Let's see here. How much time do we have? 5 minutes. Okay. I'll kick through some of the, questions? Please.
So in one of your diagrams there, you sort of showed a sort of fairly broad domain, and then you had a subset of that, and you said, this is the stuff that is actually covered by FHIR. So I'm just curious, in your consulting practice, when you go to model a domain and there's areas which are not covered by FHIR, what do you do?
Well, you're talking about, I think, this diagram? Yeah. Well, there's always a base resource. You can start from there. Obviously, extensions, you pick the next closest resource and you extend it. But yeah, base resource, domain resource, or really, we do a lot of rule of 2. So if we'll code it a one-off, and then if we see it a second time, a third time in the wild, then we start suggesting the refactors to pull it towards one of the known FHIR resources. So, and did you have one?
Yeah, so you mentioned webhooks.
Yeah.
So I'm wondering how much of that do you get from Mongo versus from Meteor or something you've done in your own framework, if you could talk more about that.
Yeah, fantastic. So we support that. So we get it from a couple of different places. Generally speaking, it's going to be from the server. The native Mongo hooks are just going in. So when Mongo upgraded to 4.0, our upstream library, Meteor, they announced 4.0 support. And as of 4.0, we get ACID transactions and JSON schema. Did JSON schema come in? Anyway, within the past couple versions. So as those come in, we get extra functionality. And we are moving the whole framework towards that so that we can leverage the native Mongo functionality. That tends to be, it's a little glacial in that it is slow moving, but it's very large and there's a lot of momentum in the same direction. And so it's just like a matter of time. 3 months, 6 months, 12 months from now, we anticipate it to get in there. In the meantime, it's mostly server-side support that we get the webhooks in. But we also get the client side too. The client can trigger webhooks on when it receives a patient on the client. And so I'd actually say server client more than database server. Well, if there are no more questions, we're going to be in one of the classrooms. We're going to figure out and announce in just a moment will be with the .NET and other folks. But you're welcome to join us for walkthrough of the tutorials, and hope to maybe have introduced you to some ideas and some libraries and some projects about how to take FHIR and how it can be extensive over the entire technology stack. It doesn't just have to be between two servers. You can actually do an entire platform off of it. So thank you very much, and hope to see you at the coding session. Thanks.